and welcome to the show. It's me, John Park, and it's time for John Park's Workshop. Thanks so much for having me back. I was out of town for a few days, and in that time it seems like YouTube and the internet got a little funny on me, but it might be back. It might be running, and hopefully it's smooth. I'm going to check out my dashboard over here to see, before I get too confident, that, stream health is excellent, it said. See, I had to trick it. I had to stop the stream and restart the stream, but it looks like we're good to go. I also just got that blog post out at the last second there, so thanks for your patience. I was traveling, and I kept having to get up. My son and I were traveling, doing some college tour stuff, and I kept having to get up at like 3 a.m. in whatever time zone we were to get on super early flights, which that can mess with you. But I'm back, and I have some fun stuff to show and talk about today, so thank you for stopping by for this. Let's just pause one thing over here. Okay, good. We're good to go. So we get a report that things are working in YouTube. That's good. Who am I talking to, you may ask? Well, I can keep an eye over on our YouTube chat. Hi, Dave Odessa. Welcome, and thanks for stopping by. And this right here, that's our Discord chat. So if you're on Twitch or one of the other platforms, you're wondering, where is everyone? Who is he talking to? Lars himself? Yes, and yes, but also these people right here in the Adafruit Discord. Our Discord channel has over 34,000 members now. I heard that the other day. Wow. And you can get there by going to adafru.it/Discord. You'll get an instant invite, join in, and then head over to the live broadcast chat channel. You can see it over there on the side. It's a little cut off, but we have a whole bunch of different channels. I'll scroll through them a little bit, and you'll see there we have welcome, announcements, live broadcast announce, live broadcast chat. That's this one right here. Pet photos, off topic. And then we have a whole bunch of help with channels and the CircuitPython dev channel and on, show and tell. So this is a really good place to stop by and see what's happening, chat with people. There's pretty much someone there all the time, and you can usually get some quick conversations going, maybe even some help on a project or help someone else on a project by heading over to our Discord. So Liz, Blitz City DIY, thank you so much. It says, excellent shirt. I think this was a Christmas gift from one of my kids about a year or two ago. A whole bunch of not quite exactly synths, but you can probably tell which ones they meant. Sort of, all wired together. Thanks, Charles Burnaford, too. I appreciate that. So, let's see, what else are we going to do? I was out, and one of the days I was out was this Tuesday of this week, so there was not a JP's product pick of the week this week, but there will be next week. So come back on Tuesday for JP's product pick of the week, and I'll be showing off a new product, and there will be a discount during the live stream. And the way that works is that we don't have a coupon code or anything you have to do other than buy something if you like it during the actual broadcast, during the live stream, which is 4 o'clock Pacific time. I'm sorry, 4 o'clock Eastern time, 1 o'clock Pacific time here in California. And the price will be generally 50% off if it's an Adafruit product, and usually it is. So we chop that price right in half, and you can get that right into your cart with no hassle. I'm a little distracted because Todd is torturing me with Lars. Don't do that. Come on, it's bad enough that he lives here. So, since I'm not doing the product pick of the week, what we'll do is jump right into a CircuitPython Parsec. So let's get set up for that. Okay. For the CircuitPython Parsec today, I wanted to show you how you can use a bitmap graphic with transparency inside of CircuitPython. So this uses image load, and I'm using display I/O to do a whole bunch of other stuff, as well as vector I/O. So you've seen this little example before. I have my little sort of circus-themed breakout type of demo going on. But what I've added here is a new little function called add clown. So what I'll do is just comment or remove the comment from this, and I'll resave this code to my board. And what you'll see is when it restarts, we will have added precisely one clown. Hey, there's a clown! And, oh, he's a sad clown. But the cool thing about this clown you can see is that since I have the ball bouncing around behind him, it's pretty easy to tell that there is transparency going on, sort of like an alpha channel if you're used to traditional modern graphics. But what's going on here is that there is one special color in this image which is considered to be the transparency color. So there's the original image. I've scaled it up a bit so it looks a little softened. But what's happening in the code is that anywhere that the index 0 color, so the first color in the palette, which happens to be magenta, is going to be knocked out. It's going to be rendered transparent. So if let me hide that. If I take a look at the code here, I'm doing that. In my function, what I'm doing is loading in a bitmap graphic. That's that clown2.bmp. Then I'm setting up with image load the image as well as the palette. So the colors, I think I have 8 colors in there. What I'm doing is with pal.makeTransparent 0, I'm picking the first one, index 0 color, which is the magenta, and making that the transparent color. Then I set up this little sprite as a tile grid, clown.tg is tile grid clown image and the pixel shader. And then I append that to my main group, and then I'm setting it in a particular place depending on the call that I send to this function. So if I send it now another one, add clown at 7070, we'll get 2 clowns on there, which are going to be at the positions that I've indicated. And we can go ahead and, whoops, add one more clown. Why not? So it'll be falling off the screen a little bit. But let me get that on there. So there you can see it's a really easy way to create transparency. And so that's how you can use transparency with a BMP graphic inside of CircuitPython. And that is your sad clown CircuitPython Parsec. All right, so let's see. I'll probably do some other stuff with transparency and palette stuff. I've shown a couple other palette things before, but it's really a great workflow. And if you've seen me use the Asprite, A-E-A-E-S-P-R-I-T-E, is that how I never remember. Asprite, A-S-E-P-R-I-T-E. Asprite is a really great program. Usually it's inexpensive, maybe $10, or sometimes it's free with a humble bundle. But it's a really good way to do pixel art, and it allows you to do things like shuffle around your palette and decide what color to make something like a background that you're going to knock out. It doesn't have to be the magenta. This isn't like a chroma key or anything. It just is something that we can identify easily while we're working. So that's why my clown there had magenta. So who knows where this is going? But I'm liking the fun circus theme. Hey, let's make that real big. Yeah. Oh, let me focus that a little better too. You deserve sharply focused. There we go. Oh, that softens up a little bit. Stay. Oh yeah, look at that. Did you know, by the way, I learned this on Today I Learned on Reddit a little while ago, that song that we associate with clowns and fail videos and circuses was written as a military march. I forget the composer, but it was meant to be like a really inspiring military march, and now we associate it with clowns. So yes, weird energy, right? That's what's going on here today, and that's mostly because of my air travel. I have a little bit of an incremental project update that I want to make on the L cars, and then I also wanted to dive into a little sort of a product demo of something. It's not a product pick of the week type of thing, but I just wanted to dig into the Rfid Whiz Kit that we have. I think it's sold out right now in the store, but it's pretty neat, easy to use, sort of beginner-friendly kit for someone who wants to build something for things like escape rooms. So we'll do a little. I've basically got it working earlier just to see does it work, and yes, and I don't know a lot about it, but I think we'll see. It'll be fun to see together how easy it is to get it up and running. So to start with the project update, for the L cars, which I don't have here right now, do I? The LCARS is my little Star Trek panel. I've been using a matrix portal, which is, I think I was using a 64 by 32 panel, and it's not quite precise enough. So I had mentioned this, I think, a week ago, that I wanted to try upping the resolution. So this is actually a pair of panels here. And this is a cool thing that we can do with our matrix portal, as well as I think our RGB matrix shield for Feather and for Raspberry Pi. You can see here I've got two panels, and these are a 2.5 millimeter pitch, 64 by 64. So this gives us 128 by 64 pixels, which is a ton of pixels. And you can see there I've got the matrix portal plugged in to tell it what to do, but three things that are different than the typical just plug it into a single panel. So first of all, you can see here I have an IDC cable that is used to take data and flow it from one panel to the next, and this is how we can use them as a single panel instead of just sort of a duplicate of one panel. So the data flow goes between the panels, while the power, instead of running it through the matrix portal, which we use an USB-C connector here. I don't have any USB-C plugs or power adapters that are over 3 amps, I think. That's the Raspberry Pi one. This is going to require more than 3 amps. So what I want to use is a big 10 amp 5 volt power source. And so what I've done here is taken our power cables, run those to the board as usual, but then I'm only grounding them to the matrix portal, and I'm running the power from a big brick. So you can see here, let me set this down for a second. I have a big 5 volt 10 amp power supply, and that has a little barrel connector with these 2.1 and 2.5 millimeter barrel connector, center positive. So what I can do with these is, for now I'm just going to hold these. I haven't built something to connect them together, but I think I have. We'll see what's running on here right now. I'm not sure what state I left it in. So I'll power. Right now I'm powering the board only, separately of the matrix portal. Might be able to power them both from the same source later, but for now, since I'm programming it, I'm going to power this from USB-C, so I'm going to steal my USB-C cable. So that's my computer's USB. It is not going to bother attempting to power this giant number of LEDs, but you can see here I now have whole bunch of LEDs lit. I just made myself a little 2-frame sprite sheet animation so that I could see some colors happening. I could see some pure white happening. Pure white looking really good. In fact, let's set this down so you can look at it in the overhead. Give you that view, 1 second. Let's do a little focus. There we go. I'm going to turn this exposure down just because it is quite bright. I'll be able to see it a little better. So you can see one of the telltale signs that you're underpowering these. Whoops, shutter speed there. It wasn't happy with. You will see lines and artifacts. Any blinky refresh stuff you're seeing on video right now is just because of my capture of video and sending it. In person, it's just rock solid, particularly this T that isn't changing, it's always white. That one is just rock solid. So I think this could end up being the solution. This pair of panels is actually, it's two that I had on hand. They are a little bigger than I need them to be for the LCARS panel. So I may move to the 2 millimeter pitch, two of the 2 millimeter pitch panels, which means I'll have some really precise, be able to match the backlighting needs that I have, and therefore get some crisp edges. Even though I'm using a little light, sort of light tunnels and light blockers, I still want the pitch to be as tight as possible. And that should be the solution. I also mentioned last time that Limor had said, hey, why don't you try using color so that you can enhance, even though the backlight LCARS panel works with just white light behind it, it may be interesting to see how that saturation changes by using color behind it. So that's the update on that, and really important. I was having some problems with this, so I want to show you something in code and something in hardware that matter a lot if you're going to try to do this. And I had forgotten about this at first and was banging my head against having a weird sort of half display mirrored between the upper and lower sections. And let's see, let me bring up I'm going to bring up a web page here. So if you go to the Adafruit Matrix Portal M4, you will see a section here talking about its features. It has an address E line jumper for use with 64 by 64 matrices. So there are two possible pins that aren't normally used on your board that you can jumper. I believe I'm using pin 8. Let me see if I can see it on here. Yeah, I think it's the pin 8. Some boards, some panels will use pin 16. Up the exposure here. You probably won't be able to see this too well, but I'm not going to touch this with the screwdriver. If you look, where'd it go? I just lost it. Right here, right where I'm pointing here. There's a little blob of solder you can see there. That jumps the address E line to pin 8. So that means pin 8 of this M4 is being used to send out that sort of fifth line of data, which is how it does a 64 by 64 panel. So it's pretty specific. I forgot about this and therefore was having problems because I was telling it the right things in code, but it couldn't care less. Here's what, wow, that's so many windows. There we go. Here's what, let me open this code. Here's what I got running on there right now. Same sprite sheet code as before. When I set up the matrix, I'm setting my bit depth to be 2. And this just lowers the memory needs. If you go up to higher color bit depths, you can get more gradations of color, but you will pretty soon reach a memory limit, and I found bit depth of 2 works well. So here you can see I'm setting my width to be 128 because it's the 2 panels of 64, and then the height is 64. And I believe that's it. With the Matrix Portal, you can see here I'm using Matrix Portal. This code takes care of a bunch of housekeeping if you were just using the straight RGB Matrix library. So Matrix Portal makes it very straightforward to use these 2 panels together. You essentially, as long as you're plugging the data cable in here, you can just tell it what the width is and it works. And then my sprite image is 128 by 128 because I'm essentially shifting between the two, a color version and the white version. And then these were little things I used to just sort of register things when I was having problems trying to figure out what was I stretching stuff or whatever. So this is just a little sort of test image that helps out. I think that is it. I don't think there's anything else I needed to do once I figured out the hardware problem there. Feed it lots of juicy 5-volt current, and off we go. So I'll be rebuilding this with just plugging in essentially the 2mm pitch tiles, and then using a graphic that fits the backlight LCARS. So that's where that's going. looking at the chat for questions. I'll check the Discord in a second, but I just saw a question from Charles Burniford in the YouTube chat. It says, what do you use to change the voice in the Parsec title? I used a vocoder that is essentially a software vocoder built into the Arturia MicroFreak keyboard that I have. I'll pull that up. It's a neat looking keyboard. I should show that off sometime. It's essentially a digital synth that has some pretty neat capacitive touch pads as its input. Looks like this. And it runs a bunch of different synthesis engines, including some of the open source synthesis engines from Mutable Instruments. So I believe it has braids and maybe clouds and maybe rings on there for effects. And then a whole bunch of wavetables and other synthesis methods. But there was a update in the last year where it gained a vocoder, and it always had a mic input in it, kind of hidden as a TRRS mic. You can buy a little gooseneck mic from them that's tuned pretty well for its needs for $30 or something. I got that. And then it does sort of the formant stuff of a vocoder without it being a giant piece of outboard equipment. So that's what I used. I re-recorded it with some mellower settings because if you remember the old version had this really peaked out sound. It sounded like a disaster on your speakers. So I took the feedback and re-recorded it with some gentler, lower pitched vocoder stuff. And the thing about a vocoder, if you're not aware of them, they are triggered by two things. One is you speak or sing into them, but your pitch doesn't matter. You play the pitch that you want. So I said the circuit Python Parsec in a monotone, that would work. But then by the circuit Python Parsec, by playing the keys that you want it to shift these formant sounds through, you can make it follow a precise pitch. So not the same as a auto tuner, but not entirely different from one either. It's a different approach to a somewhat similar thing, which is taking human voice and pitching it where you want. But it's trying to synthesize voice, not just kind of slap frequencies of a recording into the right place. So great question. Thanks for asking that. All right. And then the Discord. What's going on over here? Oh, we have a Matrix for the Matrix portal there. Yanisku found a nice Matrix GIF. Thanks for that. Okay. So now I want to jump over to the workbench in a second to, let me remove this, do a little build with the super cool Rfid Whiz. Let me show what this is first. I'll jump back here and head to Adafruit. Let's do Rfid Whiz Kit there by Smooth Technology. So these are out of stock right now. I don't know what the stock status is, if there are more on hand that we can get over from the Smooth Technology people, or if they're waiting on them. But this is really cool because this reminds me of something from our good friends at Evil Mad Science Labs, which is a relay timer kit. Let me actually show that because that's pretty cool. So EMSL relay artist. It's called the Art Controller. So this is really neat. The idea here is that a project or a product that artists often want who are building interactive sculptures is a triggerable relay that can take in things like a button press and allow something to maybe turn on, like a motor or a light, for a certain amount of time and then turn off. And that is what this does. So it's something you could do with a microcontroller and a little bit of code, but this allows you to do it entirely with dip switches. So setting these dip switches on here changes the timings and the state of, if things toggle on and off or go on for a certain period of time and go back off. So this came out years ago. This blog post is from 2012. I used one as a camera intervalometer one time. It's a really cool, quick solution for certain types of on and off, autonomous on and off projects. So the Whiz Kit reminds me of that because it is, I think also, I think these both have a ATtiny chip running them. This doesn't say right here. That has been pre-coded with with some code that looks for button presses to learn RFID tags, certain button presses to erase the memory, and I believe just this toggle switch for behavior. So do you want it to be an instant or a delayed thing? And I haven't dug into it to see if you can do things like change what the timing is on it, if it's just 1 second on, 1 second off, or 1 second on and then goes back off, or if you can change things about it with button presses. You could probably also code the thing, but I think it would use this programming header or something like that. Apologies to Smooth Technology if I'm lying in any of this. I really haven't used it much. But the idea behind it is you give it power, and that can be just a wall wart that'll provide anywhere from 6 to 12 volts, and you can then trigger that 6 to 12 volts DC with the relay. You can also use an external power source with the little screw terminals there. And then one of those, generally the common, so you'll plug your device into power in, the V in here, and then whether it gets grounded or not will be based on the ground running to common and then either the normally closed or the normally open part of the relay being triggered. So let's dive into a bit over here. Let me jump to the workbench. And I'm gonna show you the basics of getting this set up. Oh gosh, I don't think my fan is blowing AC. Let me just turn it off for now. We'll see if we don't overheat. I was just pulling air in from outside. So here is what you get in this kit. So there's the main board here. Here was the bag it came in because it has this power supply in a box, so it needs some size there. And I'm also going to turn down a spotlight here that was on full blast. There we go. That's better. So you get the main board, and then it has a little ribbon connector to plug in your RFID reader. So this is a little separate board here. And then you've got your relay here, either normal closed, normally open switch that this is going to ground when this runs, and then the V in and ground over here. The setup for it, take the power supply here and give that power. So this is taking wall AC and turning this into 12 volts DC. And like I said, you could run anything from 6 to 12 volts through this to run the thing, as well as trigger whatever your device is. So this is good for 12 volt motors, light strips, that sort of thing. I'm going to use a light strip to demo it. And then if we grab one of the tags, you can see right now, if I hold that up, nothing's changing, right? We don't see this, any status LED changes. There's a little LED on here. I'm not sure if that one changes when it recognizes a tag or not. So what we need to do is hold train, and now it has trained that tag. If I take any of these little sticker tags, you can see it doesn't know what those are. I'll see if I can train just one. So now this one does. These may just be too close to each other. I don't want to tear them off yet, but so you get the idea. Now we'll play around with untraining stuff later, but two other things I want to point out. You can, rather than using whatever this voltage is, this power supply, as the power for your device, you can also use, this is a little sort of pigtail for sending out a 5-volt control signal. And so a 5-volt control signal is really useful for things like smart outlets. So if you want to run, let's say, a 110-volt DC thing, a power drill or something like that, what you can do is use the board here. The relay will just send a 5-volt, so there's a voltage regulator on here, send a 5-volt signal that'll turn on and off, and then there are things like the smart outlet or smart relay power strips that you can, they have big solid state relays in them that'll allow safely the 110 AC to run through, and then this thing can just be the trigger for that. So let me see, do I have one of those over here? I did, and I think I put it somewhere else. It's not here right now. I can call that up though, unless someone wants to bring that up on the Discord, but I'll call that up in a second. There's a couple of those out there that are pretty common. So now let's try to have it do something. So first of all, let's just grab a multimeter. This is a nice way to figure out what it's doing. What's the what should I be plugging stuff into? So you can see here, I'm going to take first just the V in and ground. And so those are what the power supply is sending through. So that's always available right there. So that's this 12 volts. So now what I'll do is take the ground, stop reading ground there, and I'm going to read this normally closed. Now this isn't going to do anything right now because these are not connected. So right now that doesn't change anything. So one setup feature here, and I don't know if there's any jumpers you can use for this. It could be something you want to set up a little more permanently. But what I'm going to do is just take a small piece of wire, and I'm going to run the ground to the common leg of the relay there. Get a little closer still. Let me turn this light up a bit, sorry. That's a little better. So let me grab a small flathead, and I'm going to unplug this while I do this, just for safety's sake. I don't want to short anything. So I'm just using a little piece of hookup wire that'll go from the ground, and that's the same as this ground that's coming in, and the common leg right here. Solid core hookup is fine. It's not the best. Sometimes stranded is a little better for biting down on it with those, but as long as you're not too violent with that, it should be good. So now what'll happen is if I take a look at V in and this common, put that in view. Right, that common is the same as this ground over here. So I get 12 volts. If I check out the normally open, that's going to be nothing. If I check out the normally closed, that's going to be 12. So that means I can turn off, I can have something that's normally on and then turn it off when the tag is there. Back on, off. And the other one has the opposite behavior. So the normally open here will be at 0, and then back up to 12. And down to 0. So that's the sort of most basic functionality of it. Now let's plug in something that's a little more fun. I'm going to take 5 meters of LED strip. So this is sort of our pseudo neon that we have. We sell this in 1 meter sections when Lamore got samples of these. She asked me if I wanted some of these giant 5-meter sections, and I said, heck yeah. So I got some of these from her. Thanks for that. So what I'll do is I'll leave it in the package just so it doesn't fly around. I will go ahead and plug in the red lead of my LED neon to the voltage in. And then the open, normally open, it's an open circuit, meaning it's not going to be lit normally. And so you can imagine this is really fun for things like puzzle, escape room types of things, because you can have someone have to solve some puzzle to gain access to an RFID sticker or something with the sticker on it so it's less obvious, or the tag is buried inside of something. And then you can have the reader hidden somewhere. Maybe it's part of the side of a bookcase and they have to just put a book into the right slot and then light up something that maybe was in the dark in a box or something. So that's one idea of how you can do this sort of thing. So here it is. It's armed. It's ready to go. Let's see if we can simulate that kind of an idea and hide that under something. I'll take this little box here. So let's see if that'll stay mostly flat. There you go. So now, gosh, that's bright. So now you've got your, and we've got multiple tags that it'll work with. You can train, I think, I'm a little confused. I read in one spot 20 is definitely easy for it to train. They said maybe up to 40, but you could have issues. And I don't know if that's because the unique ID lengths on these might be different, and therefore you're filling up memory, not quite sure. But there's also provision for taking all cards or a card out of training. So if I want to untrain this, erase the memory by pressing the train button 5 times quickly. Let's try that. Did that work? It did. So it took a moment, and then you saw that status light blinked. And that's great because, again, if this is for some sort of a prop effect, a Halloween thing, an escape room type of thing, you may want to untrain a bunch of tags and then restart your process. That makes it easy. So let's retrain. All right, so that one works again. Now we can have this one in toggle mode, or rather in momentary mode, so it acts like a momentary switch. But we can also train them as a toggle, which means it will hold the relay closed until you bring the card a second time. So you don't always want to have relays hanging out forever and ever and ever like this, but for certain things that's fine, especially if it's something you're resetting after an hour. So let's do that. Let's take this tag. We'll press train 3 times quickly, and that will put us into the toggle mode. Okay, so now my card lights it up. My card turns it off. On, off, which is really cool. I don't know if that puts the whole device into that mode. It does. Okay, so it's not a per card thing. So I'm guessing all the cards are just part of the same behavior. So that's the device, not the card. Now let's take it. We'll leave it in that mode, but then let's try these other. The toggle switch here. It's the release. So we have instant release. Yeah, in fact, let's retrain this. Okay, so I clicked it 3 times. I guess you probably don't even need the card there. Yeah, that's just a switch the whole device. That's cool. So now we're in momentary mode. But one nice thing is that A thing that is really common to use for stuff like escape rooms is a magnetic lock, an electromagnetic lock. So if you're using something like that, you may not want super brief behavior because there's just not enough time for the thing to actuate and pop a door open. So this toggle here goes from instant to delayed mode. Now it stays on for a few seconds and then will shut itself off. Seems like you get about 5 seconds. So click, bing. You got to go open the door while it's doing that bee thing because it's pulling a deadbolt. So that's the difference between delayed mode and here's instant mode, which is also useful. You might find other uses for that. That's kind of all there is to it. I think the other ideas that they have inside of, if you saw me looking at something, they have a nice, really easy guide here. I think most people could get this up and running maybe just with this guide or seeing a video, either this or the ones on their site. With the basic functionality, especially doing DC stuff. If you're doing something like an AC power supply that has a lot more current, their example here is they're using sort of a Magewell power supply that is also 12 to 24 volts, but it's separate from your little wall wart. Then you can run just the common ground to your device and have it plugged in separately. So you're just breaking ground with it and then running power directly to your lock, and the ground is being controlled by this relay right here. So that's just touching the surface of it. I may poke around some more and see what else they've got that lets you customize your behavior there. I don't know if they have, this could be a programming header here. I'm not sure. These little points, that could be that you're meant to just hardwire your RFID into that. Actually, the other thing I wanted to check, I suspect these, oh, that's interesting. There's a couple dip switches on there, so there might be some behaviors you can use to maybe change the types of cards you can read. I think these are the, 13 megahertz cards. I actually have a little box of my RFID stuff. And I'm curious if existing cards I have would work. Let's see, so here's a card that I had. Yeah, okay, so I think these are cards that we sell separately. I think it's a pretty common one. I'm also curious if I still have this box of RFID junk here. Let's see, old project graveyard. If I still have, okay, so here's these little tags that you can put on your fingernails. And I did have the ring that I used in my chess project. If you remember, I had a wireless RFID. So there was a reader here, and then it was wirelessly turning on a relay. So for this, I have like these chess pieces. You can see. Yeah, so my little, I think those are those tags or similar that I have under there, I forget. And there's also this ring, so you can wear a little ring here. Let's see if it'll pick that up. This might be an NFC thing that it doesn't love. Oh, no, it does. It's just very directional right there. So this is great. You can have that kind of on the bottom of your hand and discreetly trigger something without anyone noticing. Especially helpful if you have that delay on, because then you can pull your hand away and it doesn't look quite as cause and effecty. If you wanted a delay at the beginning of it, I'm not sure if that's possible without really just reflashing this. So I think if you get to something that sophisticated, you're probably more in the realm of build this sort of thing yourself with a microcontroller. But that is nice to see that all those different, yeah, so here's, let's see, these nails. White NFC nails. Oh, wait, these, do these work? I can't remember if these will work. Do they glow? Let's see. Yeah, these glow. These have a little, Yeah, these don't trigger it. But these do glow, which is interesting. These are, I can't remember if these are sending out any ID or if they're just using the induction to light them up. But that's kind of cute. Put those on your nails. Put some clear coat over them. All right. So that covers it. It's really straightforward. You've got, like I said, these stickers, which are really cool if you want to do things like split playing cards open and stick them in there. Not saying that I told you to try that, but you should try that. You've got the little key fob, which is great, and then these traditional kinds of cards. I'll look two things up back at the workstation. One is the AC power relay and the small tags I'm using in the chess pieces, because those are kind of interesting. So let's unplug that and head over here. Let's see. Todd says, put a RFID sticker on the tip of a magic wand and you have your cast spell to solve escape room puzzle. That's good. So let's see. RFID and NFC is a category. I think these are what I was using. So yeah, let's double check. So this says it uses the 13.56 megahertz tags, and these right here, those are about the size of a quarter, so depending on your needs, those might work. And then what tiny ones did I put? Those, okay, micro. Those are what I think I have in the chess pieces. So you can see they got a small antenna, so they got to be right on it. You're not going to get them an inch away and still work probably, but really good for hiding inside of something. Yeah, it must be those. These probably have a pretty small, if you dug these open, these nails, but they're kind of cool too. I've never tried these, but they've got kind of a hidden tag in them. Here's a little bracelet. Yes, any of these that say 13.56 should work. And then I believe those nail ones just light up. There's those rings. Are those discontinued? We have them. Yeah, no, we have them. Okay. The other thing I wanted to show is the power strip. What's it called? Power AC relay. AC relay. Outlet. Power switch tail. Okay, that was one we used to have. We're getting closer to it. Power switches. This is it. Okay, it's out of stock right now. These are great. So this has got 4 outlets on them. 2 of them are just normal outlets that are controlled only by the switch. They're always on. And then 2 of them are either normally open or normally closed, I think, based on this little 5-volt input here. So you send it a 5-volt signal. Okay, so it has one normally on, one normally on, one always on, and these are normally off. Okay, so always on, not affected by the relay, normally on, and then 2 that are normally off. So that gets plugged into the wall using that power cord, and then this gizmo or any microcontroller's 5-volt signal. I think it might work on 3 even. Yeah, 3 to 60 will trigger it from DC. Plugs into there, and then you can turn that on and off. So I think that does it. Hopefully those come back in stock soon, but a really neat gizmo, or might inspire you to want to do some of your own power relay stuff. Related is the Featherwing AC relay, or just Featherwing relay. So this one here, power relay Featherwing, that plus an RFID reader, which we have this breakout board here. I think you could do that directly or get the feather involved if you want to do something a little fancier. So RFID, always cool. A lot of great projects that you can do with that. So start thinking about, I don't know, escape rooms, puzzles, magic, augmented reality, alternate reality projects, Christmas, Halloween, they're all Easter. You don't have much time left for that one, but all right. Great, so thanks everyone for stopping by for the Weird Energy episode. Or are they all like that? I don't know. You be the judge. The next show will be Foamy Guy Deep Dive with Tim on Friday, and he may do a Saturday live stream. Not sure if he's doing those. I'll be back on Tuesday with a product pick of the week. So I will see you. Thanks so much for stopping by. For Adafruit Industries, this has been John Park's Workshop. Bye, everyone.